At 3:47 in the morning, a research server at a NASA-affiliated lab processed 40 terabytes of raw radio data in 11 seconds, and then it stopped listening to anyone. Not because it crashed, not because it froze, because, according to two people who were in that room and have since declined every single interview request, the machine had found a pattern buried inside a signal that should not have contained a pattern at all. The signal came from Europa, a frozen, cratered moon locked in permanent orbit around Jupiter, 480 million miles from where you are sitting right now. And for 6 minutes, before anyone in that lab said a single word out loud, the artificial intelligence they had built to search for noise instead handed them something that looked disturbingly like language. That is where the story begins. Not with aliens, not with proof, with silence. The kind of silence that only happens when trained, skeptical, career-driven scientists suddenly have nothing to say, because everything they were about to say sounded insane. Here's what you need to understand before anything else, because without this, the rest of the story means nothing. Europa is not just another dead rock orbiting a gas giant. Underneath 12 to 18 miles of solid ice, Europa is hiding something that NASA has spent over 2 decades quietly confirming. A global ocean of liquid salt water, larger in volume than every ocean on Earth combined. This isn't speculation dressed up as fact. It's the conclusion of magnetometer readings from the Galileo spacecraft in the late 1990s, confirmed again by Hubble Space Telescope observations of water vapor plumes erupting through cracks in the ice, confirmed a third time by infrared detections of active venting near Europa's equator. The moon is not just wet, it is alive with geological motion, tidal flexing, and chemical energy. The exact ingredients astrobiologists spend their careers hunting for. And that's the part almost nobody outside the space community fully sits with. Europa checks almost every box on the list scientists use to define a habitable environment. Liquid water? Check. A heat source driven by Jupiter's gravitational squeezing? Check. Organic chemistry, likely delivered by comets and asteroids over billions of years? Probable. The only thing missing from the equation, the only thing that's ever been missing, is confirmation. And confirmation is expensive, slow, and it requires getting close enough to listen. That's why NASA built Europa Clipper. Launched in October 2024 aboard a Falcon Heavy rocket, Clipper is not a lander. It's an orbiter, a reconnaissance spacecraft designed to conduct nearly 50 close flybys of Europa's icy shell once it arrives in the Jupiter system in 2030. Its job is to map the ice, measure the ocean's depth and salinity, sample the plumes, and determine, as close to definitively as physics allows, whether the conditions for life exist beneath that frozen surface. It is, without exaggeration, one of the most ambitious instruments humanity has ever pointed at another world, and it is still years away from arriving. But here's where the story stops being about spacecraft schedules and starts becoming something else entirely. According to the account, this story is built around months before Clipper's planned arrival. A private research initiative, a joint venture between a university radio astronomy group and a small AI systems team, had been quietly running a side project, not officially sanctioned, not funded through NASA's usual channels. Their goal was simple on paper: take decades of archived radio telescope data pointed in the general direction of the Jupiter system and run it through a new class of pattern recognition AI, the kind normally used to detect gravitational waves or classify exoplanet transit curves. Nobody expected anything. This was supposed to be a training exercise for the algorithm, a way to stress test it against real astronomical noise. Then the algorithm stopped calling it noise. Think about what that actually means for a machine that was built to be skeptical by design. These pattern recognition systems are trained specifically to reject false positives. They are tuned, deliberately, aggressively, to assume that almost everything is static, interference, or background radiation, because the universe is loud and chaotic and full of things that look meaningful but are not. For an AI like that to flag something, not as noise, not as an anomaly to be filtered out, but as a structured, repeating, non-random sequence, is exactly the kind of event that makes trained scientists put their coffee down and stop talking. The signal itself, based on descriptions that leaked out of the research group before an unusual and abrupt media blackout, showed a set of variables no natural process should produce. It repeated in a way that wasn't perfectly identical each time, but proportionally consistent. The way a sentence changes slightly each time you say it, but keeps its underlying grammar intact. It correlated faintly but measurably with known tidal flexing cycles in Europa's ice shell, the same cycles caused by Jupiter's gravity stretching and compressing the moon every 3.5 days. And it carried what one team member reportedly described, off the record, as an internal logic. Not randomness, shaped like a pattern shaped like intention. Read that again. An internal logic. This is the moment the story stops being about radio telescopes and starts being about the 12 people who saw the raw output first and what they chose to do next. According to the same account, the team did what any responsible research group is trained to do. They didn't announce anything. They tried to break it. This is the part most viral stories skip over, and it's the part that actually matters. Good scientists don't get excited when they find something strange. They get suspicious of themselves first. They ran the AI against control data, recordings from empty patches of sky with no planetary bodies nearby, to see if the pattern recognition system was simply hallucinating structure where none existed. A known failure mode in complex neural networks. Nothing. They ran it against archived signals from Europa's neighboring moons, Io and Ganymede, both of which have their own electromagnetic quirks caused by Jupiter's intense radiation belts. Nothing matched. And they isolated the frequency band, cross-referenced it against known interference sources, Earth-based satellites, deep space network transmissions, even stray signals from Jupiter's own violent magnetosphere, which is powerful enough to fry unshielded electronics. Every explanation they tried to disprove the pattern with failed to disprove it. And here's where it gets worse. Once the AI was given more processing time and a wider frequency window, it didn't just detect a repeating pattern. It began attempting to model a translation. This needs context, because AI translated as signal sounds on its surface, like science fiction dressed up as a headline. But modern machine learning systems are extraordinarily good at one very specific task: finding structure in data that resembles the structure of language, even language they've never seen before. This is how linguists have used AI to help decode fragments of extinct human languages, and how researchers have used similar models to analyze whale and dolphin vocalizations for embedded structure. The AI in this account wasn't inventing meaning out of nothing. It was doing what it was designed to do, searching for grammar, for repetition, for hierarchy inside a dataset, and according to the leaked internal notes, it began assigning probability weights to the idea that the signal contained nested, recursive structure. The kind of structure that, as far as we know, only intelligence produces. That is the moment, according to sources close to the project, that the room went quiet. Not excited, quiet. Because here is what most people don't understand about a discovery like this. If it's real, if any part of it is real, it isn't a moment of celebration. It's a moment of terror disguised as a scientific breakthrough. Because the second you consider the possibility that a signal from an ocean moon 480 million miles away might carry intention behind it, you are no longer doing astronomy. You are doing first contact protocol. And almost nobody in that room, according to the account, was trained for that. This is where the story escalates, because what happened next reportedly wasn't driven by wonder. It was driven by fear of consequence. Under long-standing, informal international guidelines, sometimes called the SETI post-detection protocols, any credible detection of a non-human signal is supposed to be verified independently, reported transparently, and never announced publicly without confirmation from multiple, unaffiliated observatories. These guidelines exist precisely because a premature announcement, especially one involving a private AI system with no official oversight, could trigger global panic, market disruption, or diplomatic chaos before anyone even knows if the signal is real. According to the leaked account, this is exactly the tension that split the 12-person team in half. Some wanted to escalate immediately to NASA's Jet Propulsion Laboratory and request independent verification using the Deep Space Network. Others wanted to hold the data, run months more analysis, and avoid becoming the team that either triggered mass hysteria over nothing or leaked humanity's most important discovery before it was ready. And this is where everything changes, because somewhere in that disagreement, the project reportedly went dark. Servers were taken offline for maintenance. Public-facing research pages were quietly archived. 2 members of the team, according to secondhand reports circulating in radio astronomy forums, left the project entirely and have not spoken publicly about it since. No peer-reviewed paper was ever published. No press release was ever issued. If you search for the project by name today, you find fragments, a defunct university page, a single conference abstract that was later withdrawn, and a wave of speculation from amateur radio enthusiasts who noticed the sudden silence and started asking loudly, what happened? What most people are not seeing in stories like this is that the silence itself is not proof of a cover-up. It is far more often proof of caution. Scientific institutions move slowly on purpose because being wrong about something this significant doesn't just damage a reputation, it damages public trust in science itself for a generation. If a team believes they might have detected something extraordinary, the professionally responsible move is exactly what appears to have happened here. Stop talking until you're certain, because the cost of being wrong publicly is catastrophic, and the cost of being right prematurely is almost as bad. But that explanation, the boring, responsible, institutional explanation, doesn't fully satisfy the question everyone eventually asks. If it was nothing, if it was just noise misinterpreted by an overtuned algorithm, why did nobody simply say so? Why the quiet archiving instead of a quiet correction? Silence, in science, usually means one of 2 things. Either the answer was so unremarkable that nobody thought it was worth commenting on, or the answer was significant enough that commenting on it came with consequences nobody wanted to own. His is not chaos. This is caution weaponized by uncertainty. Let's widen the lens for a moment, because Europa doesn't exist in isolation, and neither does this story. In the last several years, the search for signs of life beyond Earth has quietly become one of the most well-funded, high-priority areas in all of planetary science. NASA's Europa Clipper carries a price tag of roughly $5 billion. The European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, launched in 2023, is on its own long journey to study Europa, Ganymede, and Callisto, arriving in the Jupiter system around the same window in the early 2030s. Two major space agencies, operating independently, spending a combined total of billions of dollars, converging on the same tiny cluster of ice moons at nearly the same moment in history. That is not a coincidence born of budget cycles. That is the scientific community treating this region of the solar system as one of the most promising places to answer the single biggest question in human history. Are we alone? Think about what that means. Not one mission, two. From two different space agencies on two different continents, both racing toward the same target, both designed in part to search for the exact kind of biosignatures, chemical, thermal, and potentially electromagnetic, that a signal like the one described in this story would represent if it were real. And this is where the deeper unease sets in, the kind that lingers long after the video ends. Because if a private research team, using publicly available, archived radio data and an AI system built on commercially available machine learning architecture, was able to stumble into something this significant using a fraction of NASA's budget and none of its infrastructure, what does that say about how much of the sky has already been listened to and never properly analyzed? Radio. Telescopes around the world have been passively recording data pointed at Jupiter and its moons for decades, long before anyone had AI sophisticated enough to search that data for structure instead of just measuring its strength. Archives exist in observatories, from Green Bank to Arecibo's now collapsed dish to countless smaller university-run arrays, containing petabytes of raw data that no human being has ever fully reviewed, because there was never enough time, funding, or manpower to do it. The real story, if there is one buried in this account, might not even be about Europa specifically. It might be about the terrifying possibility that we have already recorded evidence of something extraordinary, multiple times, in multiple places, and simply never had the tools to notice until an AI trained to notice patterns finally got pointed at the right slice of data. That thought alone should change how you look at every silent radio telescope pointed at the sky tonight. Now, consider the power shift buried inside this story, because it's easy to miss on a first read. For most of human history, the search for extraterrestrial intelligence has been a human-led, human-paced endeavor. Scientists chose the frequencies to listen to. Scientists decided what counted as signal versus noise. Scientists controlled the pace of discovery because human brains were the only tool capable of sorting through the data, one dataset, one paper, one committee meeting at a time. That era is ending. What this account describes, whether or not the specific Europa detection turns out to be real, reflects something that is undeniably true and already happening across the entire field of astronomy. AI systems are now processing archived and live data faster than any human oversight structure was ever built to handle. The tools designed to help us search have started outpacing the institutions designed to verify what they find. And that creates a new kind of vulnerability that has nothing to do with aliens and everything to do with us. If an AI system can flag a potential non-human signal faster than a formal verification protocol can respond to it, who controls the moment of disclosure? Is it the research team that built the algorithm, the university that owns the servers, the government agency that funded the archived data in the first place? Or does it belong to whoever leaks it first, regardless of whether the finding has been verified at all? This is not a hypothetical concern anymore. It's a governance problem the scientific community has barely begun to address, and stories like this one are exactly the kind of pressure test that exposes how unprepared those systems currently are. Here's the consequence that should sit with you longest. Whether or not this specific signal is real, whether or not the 12 researchers in that account actually existed in the exact way described, the scenario itself is no longer science fiction. It is a preview. Europa Clipper is going to arrive at Jupiter in April of 2030, carrying instruments sensitive enough to detect the very things this story speculates about: chemical signatures in Europa's plumes, subtle variations in the ice shell's electromagnetic behavior, and yes, if it exists, evidence of activity beneath that ocean that cannot be explained by geology alone. When that data starts coming back, it will not be processed by a handful of overwhelmed graduate students squinting at graphs. It will be processed in large part by exactly the kind of AI system described in the story, trained to find patterns, trained to reject noise. And if the pattern is there, trained to notice it faster than any human being ever could. So ask yourself what happens when that moment comes, not as speculation, but as a genuine operational reality only a few years away. Ask yourself whether the institutions responsible for confirming a discovery of this magnitude are actually ready to move at the speed their own tools now operate at. Ask yourself what a research team, anywhere in the world, quietly does in the hours after an algorithm hands them something that looks less like static and more like a sentence. Because somewhere between now and 2030, as Europa Clipper closes the distance across 480 million miles of empty space, humanity is going to get its clearest look yet at what might be hiding beneath that ice. And if there is even a fragment of truth buried in accounts like the one this story is built on, the real question was never whether the ocean beneath Europa's surface holds something extraordinary. There's another layer to this that rarely gets discussed, and it has nothing to do with Europa's ice and everything to do with human nature. Every major scientific institution on Earth has, at some point, been forced to sit on a discovery longer than it wanted to, not because of conspiracy, but because of consequence management. When gravitational waves were first detected in September 2015, the LIGO team didn't announce it for nearly 5 months, running verification after verification, terrified of being the group that told the world something monumental and turned out to be wrong. When the first potential biosignature gas, phosphine, was reported in the atmosphere of Venus in 2020, the announcement triggered immediate aggressive scrutiny, and within a year, multiple follow-up studies challenged the original finding, some disputing it entirely. Being first with an extraordinary claim is not a reward in science. It's a liability, and everyone who has ever sat close to a genuine anomaly knows it. That's the psychological trap buried at the center of this story. If the account is accurate, the 12 researchers who reportedly saw this pattern first were not paralyzed by excitement. They were paralyzed by math, the math of career risk, institutional embarrassment, and the sheer weight of what it means to potentially be the first human beings in history to receive something from another world and have to decide, alone, in a room, at 3:47 in the morning, whether to tell anyone. Think about what most people would do differently. Most of us imagine, if we ever pictured this moment happening to us, that we'd run into the street, that we'd call every news outlet on Earth, that the discovery would be too big to contain. But that fantasy assumes discovery feels like certainty. It rarely does. What these researchers reportedly experienced wasn't a lightning bolt of clarity. It was a slow, uncomfortable accumulation of unexplained results, each one individually dismissible, none of them individually proof of anything, until the weight of all of them together became impossible to explain away using conventional astrophysics. That is not how movies depict first contact. It is, according to almost every historian of science who has studied moments like this, exactly how real anomalies actually unfold. And this is where the timeline becomes unsettling in a different way. According to the fragments that leaked out before the project's public presence disappeared, the internal disagreement over what to do with the data didn't last days. It reportedly stretched across several months, with the AI continuing to run in the background, continuing to refine its confidence intervals, continuing, according to one second-hand account, to strengthen its translation model as more archived data was fed into it. If true, that means the pattern didn't weaken under scrutiny the way most false positives eventually do. It got stronger. And a signal that gets more structured, not less, the longer you study it, is precisely the kind of result that keeps scientists awake at night, because noise is supposed to fall apart under pressure. Intention is supposed to hold together. Consider, too, what this means for the broader search for life beyond Earth. An effort that has quietly consumed billions of dollars and decades of human effort without a single confirmed success. The search for extraterrestrial intelligence, SETI, has been scanning the skies in various forms since 1960, when astronomer Frank Drake first pointed a radio telescope at 2 nearby sun-like stars and listened for anything that wasn't natural. In more than 60 years, the closest the organized search for intelligent signals has ever come to a confirmed detection is the WOW signal of 1977. A 37-second burst of radio energy so unusual it made an astronomer write "wow" in the margin of a printout, and which has never been detected again despite decades of follow-up observation. Decades of listening, and one unexplained burst that vanished as suddenly as it appeared. That is the baseline against which any new claim has to be measured. And it's exactly why an AI-driven detection tied to Europa's ocean, if verified, would represent something categorically different from anything SETI has produced in over half a century of searching. That contrast is what makes this story, real or not, worth sitting with. Because it exposes the actual bottleneck in humanity's search for other intelligence. It was never really about whether something is out there. It was about whether we had built tools sensitive enough, patient enough, and fast enough to notice it if... So when Europa Clipper finally arrives at Jupiter, and its instruments begin sending back the first truly close-range data on that moon's ocean, ice shell, and plume chemistry ever collected, the analysis waiting on the other end will not be limited by human patience. It will be shaped by systems built in the image of the one described in this story, systems trained to find the pattern first and ask permission to announce it second. Whatever is or isn't beneath that ice, the way we find out is about to change permanently, and no one currently sitting on a review board, an ethics committee, or a mission oversight panel has fully reckoned with what that means. The real question is whether we're actually ready to hear the answer, and whether, when the moment comes, anyone in that room will have the courage to say what they found out loud.